Hello and welcome to this Stats Chats edition. Today we're talking about how to best prepare for a statistics exam, specifically a midterm opportunity to demonstrate your knowledge. I prefer to call exams opportunity to demonstrate your knowledge because test, final exam, midterm exam sounds sort of like impending doom and can have this negative connotation associated with it that triggers anxiety or performance anxiety in students. Then that anxiety competes for working memory and makes it more challenging for students to perform at their best. So just the simple act of reframing a test as an opportunity to demonstrate your knowledge, reminding yourself you've been going to class, you've been completing assignments, you've been participating in class, you've been doing some of your reading. So, all these acts have prepared you for this opportunity, just like athletes go to practice and prepare. When I used to play soccer in high school, we'd have many practice sessions before we had game day. And game day was just an opportunity to show what we've been practicing and practice. And then it's also helpful to complete some sample review items, and I'll share some of those with you as well. So how do you best prepare? Preparation is important because it can increase confidence and decrease anxiety. So first, it's helpful to use the Pomodoro technique. The Pomodoro is a productivity tool that I believe helps increase executive function, focus, and concentration. It helps you to break your tasks down into 25-minute increments and give yourself 5-minute breaks. It also provides you the opportunity to boost your dopamine along the way by crossing off each Pomodoro. There's a great app called Focus Keeper that's really helpful. If you'd like to learn more about the Pomodoro technique, if you're not familiar with it, let me know, and I'd be happy to create a tutorial for you on the Pomodoro. The next item to think about is hydration. And, it's very easy to forget to drink water. So I just recommend drinking water. It can be associated with daytime fatigue if we get dehydrated. And so that's an easy one to keep in mind. Relaxation exercises. A lot of times people get performance anxiety when it comes to test taking. So remembering to take some deep breaths. I recommend taking breathing in for 4, pausing and breathing out. So let's try it together. In for 4. Pause and exhale for 8. In for 4. Pause and exhale. Again, in for 4. Pause and exhale. And just keep repeating this exercise until you feel relaxed. If you notice that your chest is rising and falling, try to take deeper inhales. Try to fill your abdomen with air and imagine your abdomen expanding as you breathe in. Then breathe in for 4, pause, and slowly exhale. And I also recommend doing some self-kindness exercises. We've seen a statistically significant correlation between self-kindness and attachment-related anxiety. So self-kindness exercises may be linked to other forms of anxiety. So I recommend, as you're doing your relaxation exercises, to think some kind thoughts towards yourself, like I've been preparing. I have this opportunity to demonstrate my knowledge. This test is not a measure of my worth. I do not have to perform to prove myself, but I care about my goals and I want to do my best, so I will study and prepare. If you are a Christ follower or believe in God and believe in prayer and have a prayer life and could take the time to pray and commit this exercise to the Lord and ask for His guidance in studying, it can be really helpful to know that you're not on your own. God is there. There's a higher power that is watching over you, and that you can sort of cast your cares on Him, so to speak, and leave it in His hands. I recommend writing out your notes in your own handwriting. Research also shows that when you take the time to write your notes out in your own handwriting, you're more likely to recall what you've studied than when you type your notes out on the computer. So even if you type them out in class, I recommend going back and making yourself a study guide with your own handwritten notes. I also recommend using a study guide for your course if your book offers a study guide, or for example, with my statistics course specifically, and research courses, I've often recommended Research Methods and Program Evaluation, Key Concepts, a study guide. And this is a test made, this is a study guide made in conjunction with David Tetreault, who formerly served as a subject matter expert for research methods. And then I also recommend using the same process to test yourself as you have to use on the test. So for example, if there are a lot of items where you have to recall content, you can practice quizzing yourself to train your brain for information retrieval. So your brain is primed and prepared for that. And you can practice that on these sample items as well as some other test taking techniques that I'll show you with some sample items. So for example, let's look at question 1. Which of the following are 3 measures of variability? So before you answer the question and before you look at the options, I would think about what is your answer? What comes to mind when you think about variability? I think of the standard deviation. It's a key measure of variability we talk about a lot. Then I think of range, like your minimum value and maximum value. And even if you just think of these 2 items, you can start to read the options then. Option 1 includes standard deviation, variance, and range. Okay, that sounds good. Mean, standard deviation, range. Well, we know mean is a measure of central tendency, not of variability. So we can cross that off the list. Same with the last one that lists median. So we cross that off the list. Then it's between A and C. And skewness and kurtosis are a little bit different than variability, more like distribution. So A sounds like the best answer in this case, so I would pick that first answer. So you can go through that process and kind of use the process of elimination at times as well. Let's look at item 2. It says the maximum value in a distribution of scores minus the minimum value in a distribution of scores equals blank. So I would, again, think about your answer before looking at the option. So here the answer that comes to mind is range. So standard deviation we can cross off. Now inner rater range, it's got range in it, but if you haven't heard of the word and you've been doing your reading, you've been going to class, chances are that's not the answer. So then we're going to go down to the range, which is the last item, and select that item. All right, let's see. How do you calculate the variance in a data set? Okay, so this is asking for information for an equation. Now here, this is where it can be really helpful to use your notes and to try to envision the page where you wrote down this equation. You know, was it a short equation where you just squared the standard deviation, or was it a longer equation like the last item says, where you take the square root of the sum of the difference between each score and the mean, and you square it, and then you divide by n minus 1. So can you picture a denominator with an n minus 1? So being able to visualize your notes can really help with finding the answer to this item. Item 31 says social sciences researchers should always use parametric statistics. Now, one hint is that there are very few absolutes in life. So whenever we see those words like all or always or never, we want to lean towards saying that item is likely not true because there are few absolutes. So that principle will help you find the answer there. Item 32 asks about the Mann-Whitney U, if that's a non-parametric version of the independent samples t-test. So for items like this, it can be helpful to go back and envision, maybe writing down your own notes, the decision trees and mapping those out in terms of what statistical test you use when, and being able to identify if you're dealing with data that is likely non-parametric, then, you know, which, and you're dealing with the hypothesis of difference and looking at a t-test, what type of statistical test you're going to do. And so visualizing that decision tree can help you find the answer to 32. 33 says non-parametric statistics can often be considered a backup for when researchers have a small sample or data that does not meet the stringent assumptions of parametric statistics. Now here we can see that this item is much more reasonable than item 31, which had the always in it. So this is more likely to be true. And sometimes these items might be mutually exclusive. So if I say that item 33 is true, it implies that 31 is not true. So I want to keep that in mind and use the test to take the test, so to speak. Let's look at a couple more examples. Non-parametric statistics are free of all assumptions. Here again, we see one of those absolutist terms, all. So that puts up a little red flag. That's likely not to be true. Non-parametric statistical tests are free of some assumptions, like normality, but are they free of all assumptions? It can be helpful to look at your PowerPoints and write down these concepts in your notes. Non-parametric statistical tests are sometimes called distribution-free tests. All right, so you might remember your professor saying this and say, oh yes, this is true, right? And hopefully you have that written down in your notes. In a normal distribution, the mean, median, and mode are the same. Here, it can be helpful to draw a picture in your notes of a normal distribution where the mean, median, and mode are, and be able to, again, visualize that image in your notes. Item 37 says the two assumptions of non-parametric statistical tests include random samples and independent observations. All right, so knowing that these two assumptions are true, if you say true on this item, and you go back and look at 34, that makes 34 false. Non-parametric statistics are free of all assumptions. See, that would be false based on our answer of 37 as true. So we want to make sure to use the test to take the test, so to speak. Item 38 says when you reject the null and it's true, this is a type 1 error and not a type 2. Now that has a nice little ring to it, doesn't it? When you reject the null and it's true, this is a type 1 and not a type 2. So I often encourage students to use mnemonic devices to sort of sing songs or come up with raps or different ways that are fun to remember their content. Music requires so many different parts of the brain. I think of the rapping mathematician who used to put mathematical concepts to rap music to help his students recall the information. Like I remember he had one that said negative to the left, positive to the right. This is the number line dance and I could dance all night, right? And so that might just help a student recall that, the zero's in the center of the number line, positive numbers are to the right, negative numbers are to the left. And it's just a catchy way to keep that in mind. Now, when it comes to type 1 and type 2 errors, if the jingle doesn't help you to recall, it can help you to remember a visual picture. Thought this one was pretty funny. The type 1 error, the nurse is telling the man, "Sir, you're pregnant." This is a type 1 error, a false positive, suggesting that we have evidence for a hypothesis when there's no evidence there. Type 2 error is a false negative. Here's a nurse telling a woman who's very pregnant that she's not pregnant. And so that is considered a type 2 error. So hopefully this visual helps you recall these concepts with a smile. Sometimes a visual can really help with keeping concepts in mind and helping distinguish, especially concepts that can be a little tricky to remember. But I hope that this gives you some concepts to contemplate as you prepare for your next opportunity. Thanks for taking the time to review this video, and God bless your studies.